Now, let's look at an example on how to deal with second moment of area or second moment of inertia. Let's look at this question that we're given. Calculate the position of the centroid and second moment of areas about the horizontal and vertical axis through the centroid of the eye sections in figure 1. We're given two eye sections with the smaller one resting on top of the bigger one. We're asked to find the centroids and the ixx and iyy. Horizontal is iyy, vertical is ixx. So we're dealing with two eye sections. Before you start your question, you firstly need to pinpoint your point of reference. You can start from the bottom or the top, but I like to start on the outside of the whole shape. Like here, this can be our reference, or this one. Let's pick this one. That's our reference, which is gonna be here and here. And then the second thing you're gonna do is find the dimensions, the properties of these sections. When you're dealing with eye sections, you don't use these dimensions that are given. This is your height, your breadth, this is your density. You don't use these dimensions that are given here. You're going to use the dimensions you find on the table. So we look for our H, our B, our area. What else? Our I, XX, our I, YY. Same for this one. Your H, your B, area, IXX, and IYY. Let's see for our parallel flange. Do we have a parallel flange first, or so we're given a 256 by a 254 by 146 by 37. Our height is this one, which is 256. Our breadth is 146.4. Our area is right here, 474 times 10 to the 3. Our IXX, which is this one, is right here, 55.5. And for the 6. And our Y is 5.71. It's 10 to the 6. And then for our parallel flange, I think these weddings are swapped. We have a 305 by 165 by 40. Let me check. 305 by 165 by 40. And then our H is 303.8. Our B 165.1. and our area is 5.16. Our IXX is 85.5. 10 to the 6 there. And our IYY is 7.66. Confirm this one. Yeah, 7.66. Okay, another thing we're gonna need is the thickness of the web, which is our TW, and we're going to need the thickness of this flange, which is our TF. Let's also get this one, the TF, and let's get this TW just in case. Our TW is 6.1, our TF is 10.2 for the 305 one. 6.1 and 10.2. Then for this one, our TW is 6.3 and our TF is 10.9. 10.9 and 6.3. 6.3 for TW, F is 10.9. Always confirm that you are looking at the correct values, because if you're looking at the wrong ones, your calculations are going to be wrong. Now let's start with our horizontal second moment of area, which is our wiper table and IXX table. Let's call this our section 1 and this one our section 2. And section 2. The area for section 1 was 4.74. For section 2 is 5.16. Now we know that all of these areas are in times 10 to the 3. So you don't need to write this down here again. Now let's go to our wipers. The wiper for our section 1 is going to be at the center. Let me put full screen. We're moving from our reference point, which is here, going to the center of our section, which is going to be here. And we know that this right here is our B, which is 146.4. So it's going to be half of B is our wiper, which is 146.4 divided by 2 will be the wiper for this one. Answer is 73.2. And then the second one, I'm moving from our reference point to the center of the second shape, which is up to here. From the reference, going down to the center of this one. Here's where it gets tricky. We know this distance from here to the center, it's 73.2. We know this is TW, which is 6.3, and we already have half of it. So we need the distance from the center of this one to the center of this one. That's the unknown distance. We know this one, it's 73. 0.2, and then the remaining one will be half of 6.3 plus half of our height, also plus the 73.2. That's going to be a wiper for shape 2. 73.2 plus 6.3 divided by 2 plus 303.8 divided by 2. And the answer is 228.25. Our wipers are in meters. Our wipers are in meters. Our AY is also going to be this. So for AY, you times your area with your wiper. If you are lost on how we got this wiper, let me repeat it. We already have the distance from here to the center of this shape. We're looking for the distance from here to the center of this shape, which is up to here. We know this one already, up to here. So now we're left with this one. We have 73.2 for this one. And then for here, we have half of the TW remaining downwards, which is, let me see, 6.3 divided by 2, which is 3.15 remaining here, plus half of this one. So 73.2 plus 3.15 plus half of 303.8 divided by 2 is your y part 2. Now let's go to our AY. We have 4.74 times 73.2, which is 346.968. This answer, 18 times 10, is 346.968 times 10 to the 3. 5.16 times 228.25. That's 1177.77. And then we're going to look for the total of this one and this one. 968, which is 1524.738 times 10 to the 3. Our area, that's 9.9 times 10 to the 3. And then to find our wiper, our total wiper is going to be the sum of AY divided by the sum of area, which is 1524.738 divided by 9.9. Then our wiper, we're getting 154.014 millimeters from the top. This is very important because that's where our reference point is. It's from the top. Now we have our wiper. To calculate our H, our H is the sum of wiper minus the individual wiper. For this one, we have 154.014 minus 73.2, which is 80.814. For section 2, we have, if your sum of wiper is less than your wiper, you start with this one, with the wiper, and then minus sum of wiper. You're going to have your wiper minus sum of wiper, which is 228.25 minus 154.014. You're getting 70. 74.236. Then here, when you get to this point, use the full area, including the 10 to the 6. So we have 4.74 times 10 cubed is your h, 80.814 square root, and then you get your answer. Same for here. 6 74.236. 4.74 times 10 to the 3, 80.814 squared. Keep your answer in times 10 to the 6 when you get to this point. For this one, our answer is 30.956 times 10 to the 6. 74.236. Then we get 28.437. Our total here, 28.437 plus 30.956. Get a 59.393 times 10 to the 6. Our ixx and our ix-axis, we're going to use these ones that we have here. But keep in mind that our shape 1 is rotated, meaning our ixx becomes our iyy, and our iyy becomes our ixx. So this one, you're going to use it in iyy, which is here. And then your iyy will become your ixx. For this one, which is shape 2, the shape is in its standard orientation. So this one stays as ixx and this one stays as iyy. Your standard sections, you'll find them on your table. Your standard orientations, you'll find them on your standard section, which is this one. That's the standard orientation of the shapes. Also for the channels, this is the standard orientation, as well as the legs. Now let's get back to our question. For this one, we have 5.71. It's also times 10 to the 6, so let's just put this one here. And then for this one, we have 85.5. And our total is 91.21 times 10 to the 6. The last thing to do is to add these two and get your final ixx. So you're going to add this one plus this one, you get your final ixx. Your sum of ixx 59.393 plus 91.21. It's 150.6 or 3 times 10 to the 6 millimeter to the 4. We're going to do the same thing for our horizontal second moment of area. This one, just copy. The areas are still the same. Shape 2 and section 1. So for this one, we are moving horizontally from this side, going that side. See if I can clear this up. Skip the TW. Bring it down. Bring it down. Shower. And let's clear enough. Our X bar will come from this side, going to the center of shape 1, which is also the center of shape 2. So our section is symmetrical about the x-axis. So we're going to use the height of this one as our half, which is 256. Our x bar is going to be 256 divided by 2. We get 128. Also here, it's going to be 128. Since they're symmetrical, from the reference point to the center of each shape, it's at the same point. Our AX you can write this 10 to the 3 inside your areas if you want to, or you can put it on top and then you don't need to write it down here. With 4.74 times 128, you get 606.72. It's 660.48. Now total 1267.2. Our areas is 9.9. And then our X bar our sum of X bar is going to be the sum of A X bar over the sum of our area, which will be 1267.2 divided by 9.9. You should get the same X bar that you got here, which is 128. And then the H equation doesn't change, it's still the same. Meaning here we're going to have your X bar total minus X bar, then you're going to get a 0 and a 0. Your AH squared is going to be 0 and 0. Area times 0 is going to be 0. Then your Y bars, for shape 1, your Y bar is going to be the IXX, which is 55.5. Then for shape 2, it's going to be 7.66 as it is. Your totals, you have 0 this side, which is 63.16 times 10 to the 6. your sum of IYY is going to be 63.16 times 10 to the 6 millimeter 4. Let's say you were asked to calculate your elastic section modulus, which is Z AX, and your radius of gyration, which is R. For your elastic section modulus, you'll use this equation, which is Ixx over y bar. The Ixx that you're going to use will be this one, the total Ixx, and then the y bar will be this one. So ZEXX will have 150.603 times 10 to the 6 divided by 154.014. Then you get 977.853 times 10 to the 3. I think this is in millimeter cubed. So we have millimeter 4 and millimeter. One cancels and then you're left with millimeter cubed. And then for your radius of gyration, you'll use the square root of Ixx divided by the sum of area. For Ixx is 150.603 times 10 to the 6 divided by 9.9 times 10 to the 3. And then you get 123.339. You have millimeter to the 4th and millimeter squared. One cancels. We are left with millimeter squared. And then the square root of that millimeter squared is millimeter.